Exercise 9.2 Problem 5 Solution. Construct a triangle ABC in BC equal to 5 cm, angle BAC equal to 40 degrees, and the median from A to BC is 6 cm, and also measure the length of the altitude from A. Okay, it's very similar to the previous problem. So we have BC, okay, and we need to draw the angle A, that is BAC, is 40 degrees, and the altitude, the median is the midpoint. Okay, what is the median? From the vertex you join a line, you draw a line which is connecting the midpoint and the opposite vertex. So this is your median. This point is the midpoint of BC, and if you connect this midpoint to the opposite vertex, that becomes the median. The length of the median is 6 cm. It's exactly like the previous problem. Only thing is that they are also asking us to measure the length of the altitude. So what is altitude? You have to, the line has to, from the vertex you have to draw a line perpendicular to BC. Here in the median it is a midpoint, but for altitude it has to be perpendicular. Okay, so that's the only difference. Let's get going and we'll do it while constructing I'll explain it while doing the construction. Okay, so first step, we draw BC, whose length is 5 cm. Next, we draw BX at an angle of 40 degrees, right? Next, what we do, we draw BY, which is perpendicular to BX, right? Okay, then what do we do? Actually, I think I missed out, but it will come out. Maybe the animation is not right. This is perpendicular. Now we'll have to do a perpendicular bisector of BC. How will you do a perpendicular bisector? The length of BC is 5 cm. Half of it is 2.5. So let's take a radius of 3 cm. With B as a center, draw this arc. One above, one below. With C as a center and the radius of 3 cm, draw this arc. Okay. These two sets intersect with each other, join these two intersecting points, and that is your perpendicular bisector. Now this perpendicular bisector intersects BY at point O and intersects BC at point M. With O as a center and OB as a radius, draw a circle. Right? Next, so let's put one. Let's name a point K on the segment. So BKB is the alternate segment of this chord. BC is a chord and this is the segment of the chord and this is the alternate segment. According to tangent chord theorem, the angle between the chord and the tangent is same in the so it's the same angle is subtended in the alternate segment. What does it mean? You take any point, okay, and connect that to B and C. The angle it will subtend the same 40 degrees. That's what it says. Okay, that's fine. Now we'll have to, they say the median is 6 cm, right? So with M as a center, draw, with M as a center and radius of 6 cm, draw two arcs cutting the circle A at A and A dash. Okay, with M as a center and radius of 6 cm, draw two arcs cutting A and A dash. Now, what else we do? We'll have to join. So, join A and B, join A and C. The angle ABAC or ABC is the required triangle. Alternatively, A-BC is also a required triangle. You have two possibilities. So, we will take the triangle ABC. Now, what is next? We have done the median. It's like previous problem. Now you'll have to find the altitude. They are asking us to find the altitude. Altitude is perpendicular from this point, right? So what do? We'll extend this line. Okay, we'll extend BC to Z. Then from here draw a perpendicular line and measure the length, that is the altitude. Okay, how will you draw a perpendicular line? From here draw two arcs cutting this line CZ. Okay, with A as a center and suitable radius, cut this line ZC at 2 points. Then with this point and this point, draw two more arcs cutting each other. With this as a center and half more and radius which is more than half this length. So let's say this length is 4 cm. So you can take half of it is 2, so 3 cm radius. Draw two arcs with this point as a center and radius of 3 centimeter, draw this arc. With this point as a center, draw this arc of 3 centimeter. Now what you have to do is these two arcs intersect at one point. So join this point and A. Okay, so this is the altitude of the triangle, and measure this, and that is 3.8 centimeters. Okay, and let's name this intersecting point as E. So AE is an altitude and the length of AE is 3.8 centimeters. So only this depth, okay, is extra here. So how did we do? We extended this line, and then from this point we took suitable radius to draw two arcs cutting this CZ line. Okay, CZ is a line, cut that line at 2 points. And what you do, you take one more with this as a center and take a radius which is more than half of this length. If the length is 4 centimeter, let's take 3 centimeter radius and draw an arc with the same radius, and with this as a center, draw one more arc. These two arcs will intersect each other. Join the intersecting point to A, and that is your perpendicular line. It will cut ZC at one particular point, and that is E, and AE is the altitude, which is 3.8 centimeter. Okay, so let's go through the construction. So draw a line segment BC. So we did this BC of 5 centimeter length. Then at B, make an angle CBX equal to 45 degrees. At B, make an angle CBX is 40 degrees, right? Oh, it's 45 degrees. I'm sorry, we need to check which one is right. Okay, please check which is right. I'm not sure, I missed it out. Then draw BY, which is perpendicular to BX. Then we have to draw, so we have to draw a perpendicular bisector of BC, which meets PY at O. So what did we do? We drew this perpendicular bisector of BC, which meets the BY at O, and at the same time it intersects BC at M. Right? Next, with O as a center and OB as a radius, draw a circle. With O as a center and OB as a radius, we drew this circle. Right? Then the segment BKC contains the vertical angle of 40 degrees. Right, I think it's 40 degrees, it's not 45. Okay, you can correct it. So then what did we do? We put we labeled a point K on that alternate segment. So this alternate segment BKC, right, contains the angle 40 degrees. So when they say contain, any point you take on this alternate segment BKC and join that to B and C, it will subtend an angle of 40 degrees. Right. Then with M as a center, draw an arc of radius 6 centimeter meeting the circle at A and A dash. What did we do? With M as a center, we draw two arcs cutting the circle A at A and A dash, and the radius of the arc is 6 centimeter. Then what else? We join A to B and A to C, and ABC is a required triangle. Alternatively, A dash BC is also a required triangle. Both are same. Right, both are required angles. So let's stick on to ABC. Then complete, that is what they say, complete the triangle ABC, which is one of the required triangle. Triangle ABC is also another required triangle. Then produce CB to CZ. So we have CB, produce that, extend it, okay, to point to up to Z. Then draw AE perpendicular to CZ. So because it's altitude is always perpendicular, right? So you draw a line perpendicular to CZ. How did you draw the perpendicular line? From here, with suitable radius, you draw an arc which will cut CZ at 2 points. Then from here, with the same radius or slightly more than half of the this length. Okay, if this length is 4 centimeter, you can take 3 centimeters. With this as a center and 3 centimeters radius, draw this arc. With this as a center and radius of 3 centimeter, cut another arc. These two arcs will cut each other at one particular point. Join A2 to this point. That is a perpendicular line. So that will be the perpendicular to CZ. Okay, and it intersects CZ at particular point E. So draw AE is perpendicular to CZ, and this is the altitude. You measure this altitude AE, which is 3.8 centimeter if you have done correctly. Okay, so I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.